Good afternoon, everybody. My name's David Zabka here, and today for the 30 at 3 live, we're going to be looking at different vertical brace connections and some of the things that we can do with our vertical brace connections. Just kind of the reason why we're doing this topic today, I have had quite a few emails and calls about vertical braces, some people having troubles with those and whatnot, so I thought it'd be a good topic here today to just touch on to maybe give some people some tips here, a few things that they might be missing to help out. So just the first thing to start off with here that I want to mention, different material types that we can design connections for with vertical braces would be wide flange braces. We can do tube. With a new release that we had last Friday, we can now do round pipe. We do angles, double angles, and WT connections also. So I just have a real simple model here. I think a lot of you have probably seen this model before, but it just kind of gives a couple good examples here of our different brace connections. So we have pipe over here on this side of the building. We can see WT tube. We have our wide flange braces there, have our double angle braces over here. So we do see some failed connections, and I'll kind of touch on those, on why those are failing. Another thing here, as you're inputting braces, so as I input these braces, I'm using the brace command up here, and what I want to watch out for here is our structural usage. So if I select that brace, just to show you here over on the left, I'm going to need that structural usage to be set to vertical bracing. If that's set to other, SDS2 Connect is going to try and treat that like a beam. It'll try to just create like a simple shear connection or clip angle like it would for a beam connection. So watch out for that. Another thing to take note of is if we're framing into the intersection of a beam to column connection here, the beam, the supporting beam, has to have a connection before we can create one for the brace. What's going to happen is the brace is going to use the same connection type, whether it be shear plate, clip angles, or end plate that the beam connects to the column with. It's also going to create that same type of connection to connect the gusset to the column. Okay, so in this case, if I take a look at the beam connection then to find out what's failing, so something we typically see quite a bit of, so I want to give the example. It tells us SC or slip critical bolts are required for slots or oversized holes. Now this only applies when there's an axial load, tension or compression, and we can see we actually don't have any of that in here right now. The reason why there would be axial forces applied here is because SDS2 uses the uniform force method to design braces, which transfers those forces into the beam connection. We can actually turn that off. There's an option in setup. I'll go ahead and show you that here, where to shut that off. It is best to have that on. If you shut that off, those forces are not taken into account with connection design. I just want you guys to all be aware of where we turn that off. So in our setup, if we go to design criteria, we have an option over here to add the gusset beam interface forces to the beam. Like I said, that's going to turn that off so the forces aren't automatically added into the beam connection. The other thing we can do here, the option above that to redistribute the gusset beam interface force to the gusset column connection, that would be, basically that's referring to using special case 2 of the uniform force method. Okay, so that is going to transfer the forces to our gusset column connection rather than beam to column. We can also change that option right here in the edit screen of our vertical brace. I can set that to yes, so that those forces are not transferred to the beam to column connection then. I'm going to go back here change that to slip critical bolts, and it looks like now we're getting our connection, so hopefully this will work. If not, I might have to make another adjustment. Okay, now we get our connection there. So there's a couple things I can do there. That's just one example of what we can do there. Something else we might be able to do, like down here on this brace to the base plate here, tells us our maximum gusset thickness is exceeded. So in setup, there's an option to set the minimum and maximum gusset plate thicknesses. Okay, so this failed message here is telling us we're exceeding that max gusset thickness. Well, in this case, I have grade A36 set as the plate in the connection specifications. So maybe we want to try a stronger grade there. Maybe we can use A57250 to design that connection instead. Use a stronger material. We're going to be able to use a little bit thinner plate there then. Okay. Other things you can do here with the wide flange braces. I'm going to go over here and edit this other side. And back again in the connection specifications, we have a connection arrangement. So now it's just kind of what we call a standard connection. If we want to do a paddle plate connection there, we can do a little bit different configuration. Okay. Maybe if this brace is rotated 90 degrees, so our web is horizontal instead of vertical to the world, okay, we get a little bit different connection there again. Two different configurations that we have with that also. Again, in connection specifications for the connection arrangement, maybe I want flange gussets rather than the web claw angles. So we're going to see something like this. And one thing to take note of here, the clip angles are actually being welded to the column and to the flange plates, just like everything else so far in SDS2 Connect that you've probably seen. We don't actually display the welds, so they are all taken into account for connection design. They're just not displayed. So another thing to look at over here, your tube braces. Okay, currently we're getting a tube brace created with a connection that would be field welded. So again, no welds displayed. They are taken into account when we design the connection. The big hole that you see there is kind of used for fabrication purposes. So a lot of fabricators want that hole in there so that when they run this through their CNC machine, it'll just drill a hole in there, and then they can go ahead and manually cut out the rest of that notch there. Makes it a little easier for them if they don't have a machine that is capable of doing that whole notch there. Editing this connection then, I have a couple different arrangements then, just like I did for my wide flange braces. So if I want this to be bolted instead of welded, we can do that. Okay, so we get something like so. Another option that we have is a paddle plate. So we can do a paddle plate here also. Okay, I think that's about all I have for this week's on the vertical braces. We're going to go ahead and leave it open to questions that anybody has. There should be a questions section on the GoToWebinar toolbar there. If you guys want to go ahead and type any questions that you have in there, I'll go ahead and repeat that to everybody so everybody can hear what the question is and hopefully get an answer to everything. If I don't have an answer for everything or don't get to the question during the webinar, I can email everybody afterwards. So we'll go ahead and open it up for questions here. So first question here, what do you suggest is the best workflow for inputting in brace forces. So I assume basically what the question there is, let me get this window out of the way here. I assume what the question there is, if I edit this brace, what we're looking at here, if we have an automatic load, currently the 59.07 that's being calculated there is calculated based on a setting in our setup. Go in here and show that to you. So in design criteria, we have an option for the percent of allowable tension and compression. So right now we have 50%, and when that is selected on auto, like I showed you, 50% is going to be filled out for you there. Otherwise, you'll have to manually type in any design loads that you have. You probably may have noticed for this version that we have now, the latest version, we can import fast track forces. So that would be just a simple import from a fast track building designer building, and we're working on getting others from RAM, RISA, those other types. So look for that in future releases. Hopefully that answers the question here. I think that's what we were getting at. So another question here says, often I get an error message that says gusset extends past the end of the member on the bottom of my columns. How do I fix this? Well, typically what the cause of something like that would be is, in the case that you see here with a column, I'm just going to edit the column connection, and I can set that to auto standard. In this case, it's not going to generate a base plate. So we're going to see that particular failed message that the gusset extends past the end of the member. So without that base plate there, SDS2 Connect sees that it's trying to design a connection with that gusset below the column, can't do it. So we're going to get that. We'd need to add the base plate there. Next one, does SDS2 design support Canadian design? The question of that should be yes. In our setup, if you take a look at the design criteria again, okay, we have a connection design method. So in here we have two versions of the Canadian design code. We have the 8th edition and the 9th edition currently in there. So if you need to design for that, go ahead and select that in here. Another one here, for X bracing with the double angles, is it required to split the two angles that get the connection across the single angle, or is this automatically handled by SDS2 Connect? And the answer to that would be SDS2 Connect does handle that. So I think what we're looking at is a situation like this over here. We input, or actually when I input this model, I input these two braces as, actually I would have input as 3 braces. So we have one going the whole length, and then one to the center of the full length brace, and another one, and then SDS2 Connect went ahead and generated that plate for me and everything. So that should be handled. Can you run calculations on braces is another question here, and yes, I can run the calculations. I'll go ahead and show that quick. I'm going to show it with this brace up here, so if I want to see the calculations for that, hit my report, go ahead and select the connection I want to run that on. Just to expand that a little bit, so we get the calculations. One thing I'll point out in here is, I mentioned it earlier about the forces being transferred to the beam column connection. Tells us I turn that one option on. That I mentioned was special case 2 out of the AISC books. We can kind of see that going on there. And you also have the expanded design calculations also that we can take a look at. Remember, those are we'll only be able to open those in Firefox, so need that to view the calculations at this point. Another one here, can you show how the loads from Fast Track are imported? Currently, I'm not going to go ahead, I'm not going to be able to do that currently, and the reason why is because I don't have a model currently imported from Fast Track. So actually the way that that works is, you'll notice I actually have a CSC Revit integrator up here. So what I have to do is I actually have to import the model into Revit Structure from CSC first, and then I use the same file to import the end reactions using our import fast track forces here to the ends of the members to design connections. So I don't actually have a model imported. It does take a while to do that. I don't want to take up too much time. I can tell you, though, that I had planned on the next webinar being focused strictly on importing those forces from Fast Track. So I would definitely come back in 2 weeks for that webinar to watch that. In the meantime, just real quick, like if you're interested in looking at that a little bit, if I hit the button up here, there's a documentation link. That'll take you to a PDF on our website that kind of goes through step by step and kind of some of the documentation for that to get a little more information in the meantime. So okay, another question, even if I cannot see the welds, can I edit them? In a lot of cases, yes, you'll be able to edit those welds. So let me find a situation here. So I believe if I just edit one of these braces here, in my design details, okay, if you're familiar with SDS2, these would be similar or the same thing as what we call revise and review fields. So if I change this to a user connection, I could go ahead and edit that weld, then change the size of it. So it is possible to edit those welds even though you can't see them. Like I said, our design calculations are going to have those taken into account and everything. So So another one here, can you demonstrate a truss connection? So I do have just a maybe a real simple truss like you see over here, and actually I'm surprised because at one point in time Revit Structure had a problem handling the completely vertical braces like we see here. So I just input these as vertical bracing just like the others were input. So it's nothing really too special here, but we do get connections generated here for us. So everything is pretty much the same as our other braces there. So. Another question here, I noticed the analytical working point went to the top of steel, but the physical model went to the center line of the beam. How is the connection designed? In this case, I input those like we typically would in SDS2. So in SDS2, we're typically designing connections, especially with vertical braces. We're inputting our braces at half the nominal depth of those beams. Those connections are going to be the same way, done the same way here in Revit Structure with SDS2 Connect. Looks like I skipped somebody here. I missed it. Another question here. Sometimes we use X bracing in bays that contain joist and joist girders. What would you suggest for getting a connection for this framing situation? Well, if you're talking bar joists like we have over here, currently SDS2 Connect doesn't do any sort of connections within Revit Structure to bar joists, anything like that. You know, if it's just a wide flange that you're talking about, it's going to be done really the same way. So there would really not be any difference in that case then. What about if one of the beams or truss cords is sloping? I think this goes back to the question about the truss connections. So the question is, what if one of the beams or truss cords is sloping? How does SDS2 handle the slopes in the connection design? We should be able to, it should handle that. We should be able to design calculations, design connections to sloping beams. If you had even sloping columns also, I know that does apply to the truss really, but sloping columns we would also be able to design the brace connections too, so we should be able to do those. Again, when you're inputting those, it can be kind of picky on where the work points are at, so pay attention to where you get your work points. If they're in the right spot, typically half the nominal depth of the beam, like I said, will give the best results. So as long as we're getting that correct, we shouldn't have any problems with that. Just making sure that I didn't miss any questions here. And actually I did see another question. Can you illustrate a seismic brace connection? I can go ahead and do that. I'll show you what we have in here for that. I'm just going to come over here to my brace connection. Now this can be done a couple different ways actually. For the seismic, in our setup we have an option to turn on our seismic brace connection so it applies to the entire model. And that's going to be in design criteria. We have a seismic vertical brace gusset design. So if we turn that on, kind of what's going to happen is, let's take a look at another option in plate design criteria. We have a multiplication factor for the distance between free end of the brace and line of restraint. So that's going to pull the brace back, in this case, 2 times the thickness of our gusset from that fold line on the gusset. So I went ahead and I actually canceled out of there. I'm just going to run the seismic gusset design on this one. And to do that, I could go ahead and change that option here in the edit screen. I could say yes to that. It should treat this one now as a seismic, so we can see we get a little different design there in our gusset and the setback. So, okay. Another question here is, can you change the setback on a brace for erection clearance, i.e. make the HSS shorter to allow for it to swing in place? Okay, that should be no problem. In the edit screen, actually a couple things I'll show you here. In the connection specifications, we have a notch length clearance. So what that's doing is specifying the clearance for that notch from the gusset. Or if you want to actually change your setbacks, go into the setbacks here. I can set that to an input minus dimension if I want that to be, 1'6" here instead of what I got. I should be able to go ahead and do that. And it's going to adjust that connection for the setback that I input there then. Okay, again, I'm just going through making sure I didn't miss anybody. Looks like we got everybody's questions. If there's any more, please go ahead and ask them now. If not, okay, not seeing any questions, we are going to go ahead and do kind of another promo for everybody to purchase, and I will go ahead and turn it over to Michelle McCarthy here and let her explain to you what we're doing for that, and she'll finish it off. Otherwise, I'll be back again in 2 weeks to do another one for you guys here. So everybody have a good day.
Thanks, David. So what we're doing for you guys this week with the 30 at 3 live, if you purchase from 1 to 5 licenses, this is good for. If you purchase by the end of business, 5 p.m. tomorrow afternoon, we'll give you 1 year of the standard support package to go along with your licenses, and that's good for up to 5 licenses. So the way you do that is go onto the website, sds2connect.com, go to the purchase area, and you'll buy the license, however many licenses you buy. Don't select a support option there. Do not buy support. Once you've bought it, give me a call at Design Data, and then I'll take care of getting you guys enrolled in the support program. My number is 402-441-4000, and just ask for Michelle McCarthy. If you want to email me, you can do that as well. Email me at Michelle, M-I-C-H-E-L-L-E, at SDS2.com. And like I said, by the end of business tomorrow, 5 p.m. Central Time, and it's good for 1 to 5 licenses. Thanks, and we'll see you in a couple weeks.